Dr. Saab, we can start.
Hello, is it
Yeah,
audible?
we can
Sir?
start. We can start.
I welcome all the participants of the National Workshop, a 5-day workshop on advanced research methodologies in agriculture extension. Today is the second day. Discussion for the topic of today's is on meta-analysis, how it can be used in our extension research. It is going to be dealt by Dr. G.A.K. Kumar, and he's working as a principal scientist and head of the social science division in National Rice Research Institute, Cuttak, and he is well versed with the research methodology and also entrepreneurship development, and also is having so many projects of DST and also NASO projects, and he has guided many of the students, PG and PhD students. He had very good publications in the reputed journals, and he is having versatile character, and he is very much interested in making aware of the extension fraternity in the fundamentals of extension research and also advances in it. With this few background brief biodata of Dr. G.A.K. Kumar, I now hand over the mic to Dr. G.A.K. Kumar to deal with the topic on meta-analysis. Thank you.
Okay, Dr. Saab, thank you so much. First of all, I would like to thank you in person because it is because of you only that I have joined this. Okay, this very important workshop. And so can I know a little bit about the profile of the participants so that accordingly, I will have my discussion.
Sir, we have extension faculty all over the country, sir. ICAR institutes are there, SAUs are there, and also PG and PhD students of SAUs, sir. This is the profile name.
So majority of them are students?
Not, sir. Faculty also. I think 3/4 are faculty and 1/4 are students, sir.
Oh, okay.
And about 15 students, sir, right now in this hall is there.
Okay.
I have not joined the link. They are physically available here.
Bapatla Kattu building.
Is it okay, sir? Dr. Kumar?
Yeah, that's fine. That's fine. So, no, because actually, what I would like to do is I would like to start with very fundamental things about our extension research. So first of all, I would like to have pardon from all my scientist colleagues because they may not take me otherwise, asking so fundamental questions about what is the purpose of extension research and things like that, because that will, Dr. Saab, lead to a very meaningful discussion throughout today's session. So my first question to all of you is, why do we do research? Any one of you, particularly youngsters, I would encourage, because 1/4 of you are PhD and MSc students, freshly graduated, post-graduated. So you should tell us that why do we do research?
Sir, I'm MSc first year student from Agriculture College, Bapatla.
Okay.
We do research on a particular topic to analyze that particular theme or a situation in brief. Other than what we know, means we collect the secondary data So other than that, in order to analyze more in that situation.
What's your name?
Sneha, sir.
Sneha. What you answered is correct from what you are saying from your perspective as a first-year students of MSc. But I am asking the fundamental purpose of doing research. You know, you are telling about what we do while we conduct research.
Sir, good afternoon. My name is Agilesh.
You can keep seated. Let us not stand.
Thank you.
Everybody can keep seated. Yeah, please.
Okay, sir. My name is Agilesh. I am doing MSc second year in Agriculture College, Bapatla.
Yes.
In my opinion, research we are doing to solve the problems that are faced by the farmers or any population divisions, and we will study the problem and we will find out the solutions for that problem through the research.
Still, my question is unanswered. I may take few minutes on this. Please don't mind other senior colleagues of mine. The very fundamental of why there is a need to conduct. This is okay that you want to solve the problem is one way of telling that why we conduct research. But still, I want to boil down to even more fundamental, kind of reason for conducting research. Yes.
Good afternoon, sir.
Yeah, please go ahead. Introduce
Yes,
yourself
sir.
and go ahead.
Sir, research, it means search for knowledge. That means in research, we're trying to find something new. We are trying to find something new which has not been yet explored.
Good, good.
So,
You are very,
that
very
is-
close to my answer. What's your name?
Sir, my name is Dehnia. I'm from Skost, Kashmir.
Okay, somebody from Sife, Atufa. She has written in chat box to discover the truth. Very, very close to the answer. Very, very close to the answer. Okay, great. So let me take back to when we started our extension research in late 50s and early 60s, or let us talk about any discipline of science or other so-called non-science kind of social science or something kind of thing. So what you do first you want to find out what is what. What is what. This is something we try to find in any subject. When the subject starts, so you try to find out, just like I can give you the example of archaeological studies. So they are just finding out what are the things. Okay. So that is first thing that we do for finding what is what. Okay. Or what is where, you can say. Okay. Then once you come to know about this, let us say in today's terminologies, that adoption or diffusion or education, age, all these things, So first we try to identify all these things, what is what. Okay. So that is first thing that we all find out. Okay. Then we try to find out in certain cases what is where. Okay. If you find out already what is what, then that what is where it is. Okay. Then how one thing is related to other things. Okay. That's the third stage of it. Suppose if you have unearthed X and Y can be any variables. Okay. So now you would like to know that how X and Y are related or not related. Okay. So up to this, I think I have made it clear. First, you try to find out the different, if I say in today's terminologies, that you try to find out the variables and other things that are operational in the social system. Okay. So all the psychological and sociological variables we have tried to identify in our earlier researches. these are the things which operates in a system. Then we try to find out where it exists, okay, and then we try to find out how they are related to each other, okay. But some very good chat box, I think people are giving. I'm happy. I'm very, very happy. So the third stage is you have found out the relationship between different what's, whatever things you have found out. Now you try to find the relationship between those things. So in extension, so far, we have been doing this research of finding y and also finding so many x's which are affecting y. In another terminology, what these x and y's are called? Tell me, students particularly, tell me.
So dependent and independent variables.
Fantastic, fantastic. So we call them dependent and independent variables. Fine. So now you came to know that x is and y are related in some way, either linearly related, collinearly related, or in whatever formula way they are related. Okay, that means the dependent variable, some changes can occur because of the independent variable. Okay, so what are those studies that defines this, that there is relationship? What statistics you use for that?
Regression analysis.
Pardon?
Regression analysis.
Regression is one step further. Before that is correlation.
Correlation also, sir.
Yes. So first you have used all the correlations, and then you have established in our extension research, we have almost found all the variables. That is what is almost done. There can be new variables. It is not some place where it will all stop. So some new variables can be there. So we have done what is where, and how these what's are related to each other, correlation, and how much change does it bring to dependent variable, that is regression. The answer somebody gave just a little earlier. So you go for regression, that okay, if you make a unit change here, what effect it will make, and you measure that with R square. Am I right? That what is the percentage? What is R square indicates? Suppose R square is 0.8. What does it indicate?
Yes? 80% of the variation in the independent variable. Dependent variable explained by the independent variables, what we take into the model.
Very fantastic. So 80% of changes in dependent variable can be explained by this set of independent variable, 5 or 10 or 12 or whatever. Okay. So that is what you have done. So what? Now we have found out what it has done, how much changes it is bringing. So what is, how do you generalize them? Suppose if I think about only correlation. Okay, let us talk about the correlation. So many of you, particularly those who are in PhD and those who have already completed PhD and are senior professors and all, we must have come across many studies, okay, where any two variables are studied by say 20, 25 people or 50 people, okay, and do you think they all found the same kind of relationship? I'm talking about in three terms, not the value of R, but let us talk about in three terms: either significantly positively correlated, significantly negatively correlated, or not correlated, or uncorrelated, whatever you say. Okay, so these are the three categories of correlation studies. Am I right? Am I right when I say this? Can we say that two variables can be either uncorrelated or they can be correlated? If they are correlated, then they can be positively correlated, positively significantly correlated, or they can be negatively significantly correlated. Is it okay to all of you?
Yes, sir.
Okay, good. So, can you please tell me, if you have done review of literature, have you found out that all the studies are showing the same thing, that any x and any y, a set of x and y, are in all the studies are positively significantly correlated? Have you seen any such kind of scenario? If you're not seen, say no. Okay. Seema is telling yes, sir. Is it so? But Santosh is telling no. I think I will have to agree with Santosh, because when you go to review the literature, you will find that there are n number of studies that are showing significant, and there are maybe a small number or whatever number are also showing that they are non-significant. And some are saying they are positively significant, and some are saying they are negatively significant. To that extent, the result varies. And if everybody of us will agree with Santosh, first of all, I understand that all of you agree with this, then tell me, who is correct? Those who are saying that two variables, any set of variables are positively significantly correlated, are correct, are right, or those who are telling that it is negatively significant correlated are right, or those who are telling that it is non-significantly correlated are right, or they are uncorrelated kind of thing. Okay. Please tell me, who is correct among three of them? When I say three of them, means three group of studies. Anush is telling it is based on results, sir. Yes, of course it is based on results. But my question is everybody's results correct, or two of them are incorrect? This is very generalized statement. It depends upon situation. You have to be specific. What situation you mean? You are right, but what do you mean by saying it depends on situation?
So the situation and the study.
Okay, what is that situation represents? What is that factor? I'm telling dependent and independent same variable. Ramadevi, I'm telling that it's the same dependent, same sample size, population type. Somebody, Dr. Satyanarayan is writing. Okay, sample size does affect the results. Okay. But since answer are coming very close to my actual answer, I will tell you. It all depends upon where you have drawn your sample from. Because in a population, you have drawn your sample, yes, errors factors, yes. So you have drawn your sample from a typical place or typical locale. So in that locale, even though it is part of the whole population, your sample itself is having that kind of sampling error. Okay. And because of that, varied kind of results we can see. But that does not mean that any of the results are incorrect. In fact, all of the results are correct. Do you agree with this? I think many people have already said it depends on situation and all, Dr. Ramarao. So I think, yeah. So all are correct. It's only a matter of fact that where from you have drawn the sample. Okay. So that is how all the results are correct. And there is a need. Now, let us come to the next stage. As a MSc PhD students, you review some 20-25 researches, thesis or other researches. Okay. And then you have got some 10 saying one thing, another thing, and third 5 saying the third thing. Now, how do you journalize that? Dr. Patel, welcome. But you have missed the discussion. Okay, Dr. Deepak. How do we journalize? Suppose you have got 10 positively correlated studies, 10 negatively correlated studies, and 5 uncorrelated studies. Then what is your generalization of these 25 review of literature?
Sir, we try to relate it with our study, like what we are doing. We try to relate these reviews with our studies, with our variables.
So what you do is, in your, suppose you might have taken 100 sample or 200 sample, and in your study it comes positively correlated, then you say, yes, see, this is also coming in all these 10 cases. That's what we say. That is what we say.
Relatably, we can say that.
Pardon?
We can say that somehow.
Yeah, but I am saying, when you say your study is similar to 10 studies, then you are ignoring 15 studies. Okay.
Yeah.
So that means there is no value of these 15 studies which were telling that it is unrelated, or which are telling that it is negatively related, negatively significantly related. Am I right?
Yes, sir.
So do you think this is right kind of review of literature or presenting review of literature?
No, sir.
Yes. Who is telling this? I just want to know who was just interacting with me.
Sir, Tehnia.
Tanya. So
Yes, sir.
Tanya, I take your words as a representation of all the participants. Okay.
Yes, sir.
You got some 200 plus participants.
Sir,
So,
in case of, sir, excuse me, sir.
Please.
Sir, in case of social sciences, it is the scenario. But in case of physical sciences or biological sciences, usually the relationship between independent and dependent variable remains same in all the situations.
You are not always right. You are not.
Yeah, most of the times.
Maybe that probability are more in physical sciences, but you might have come across contradicting results in physical sciences as well. Okay, they also report contradictory research because of many factors. That we may not go into those factors, because here we are will be only talking about some aspects related with meta-analysis. Okay. So, Dr. Prashant Kumar, you have some doubt. Can you come to the mic and tell me? We didn't get. What is that you didn't get? Okay, so let Prashant Kumar switch on his mic, and then we can talk to him. Okay, so till this time, this is what we have been doing. Okay, so way back in 88-90, when I did my masters, I also came across this kind of problem, that this is the different kind of studies that we are coming across, and this is the way we generalize. We try to say that, okay, my result is tallying with this many researches, and it is not tallying with another set of researches. That's all. But that is not generalization. Okay, that's not generalization. And if you remember that why we do conduct researches, So the next step after you have done correlations and other things is that can we actually generalize? Can we actually generalize from different studies? And these generalizations are not only restricted to the study area, but it is applicable to a vaster area, maybe at the state level or the country level or the regional level or whatever, something like that. So that is something what meta-analysis provides us a solution. Okay. So how many of you have heard about meta-analysis earlier? Or if any one of you have heard about it, you can just raise your hands. Okay. We have few people who have heard about it. Good. Good. So can I ask you what is meta-analysis if you have heard about it?
Analysis of analysis. Means,
oh, great. That's the word. Meta-analysis is analysis of analysis. Sri Chandan Das, what are you?
Yeah.
PX?
Yes, I am from CIF Mumbai.
Oh,
I work in OUAT.
Oh, you work in OUAT as?
Principal Agro-Polytechnic Center, College of Physics.
Oh, great. That's great. That's great. Great. So I think you are absolutely right when we say meta-analysis is analysis of analysis. Okay. Now before I will start my slides, I just want to tell you one thing. Please don't get into the statistical part of it or any kind of thing. Okay. We are doing some very, very simple things in meta-analysis. That is, let me assure all of you about meta-analysis. And henceforth, let us try to use that also. Okay. So what we are doing in meta-analysis basically, okay. Suppose if you have all the correlation values, whether negative, positive, or kind of uncorrelated value, okay, which may be say 0.1 or 0.2, something like that, R value. So that if you add them all, if you add all the values, okay, and average them, we will get something very close to one figure, and that figure should be good enough, average of it. And that figure, if it is positively correlated, we can say that, okay, these two variables are positively correlated. Or if it comes as negatively correlated, we can say, yes, it is negatively correlated. Or it comes as uncorrelated, we can say, okay, these two variables are uncorrelated throughout all 25 studies. Can we say this? Any harm in saying this? Yes. I'm expecting some answers. I took the example of, correlation. 10 correlations are positively significant, 10 correlation values are negatively significant, and 10 correlation values, 5 correlation values are non-significant. So if we add all these correlation values, 25 correlation values, average them, and whatever value it comes, can we say that that is the right value? Seema has said yes, sir. Somebody from KVK Malkangiri is saying yes, we can say sample size will be more. Yes, that is true. And Sri Chandan Das from CIFA is saying no, sir. So Dr. Das, can you say why not?
Sir, the sample size may be different for all the researchers. Their conditions may vary and depends on not only the result of an individual research based on its prior conditions and sample size.
Okay. Okay.
So it may not be same for all the 10 researchers. So you cannot take all the average.
I think, Dr. Das, your concerns are very, very valid. And let me assure you, this I just started with the very first step, okay? And let me assure you, this meta-analysis takes care of all those concerns, what you are saying, okay? Fine. So let me share my slides. Okay, can I be enabled to share my slides? Host, please.
Sir, it is enabled. You can share it, sir.
Okay, good, great. Is my slide visible to all of you?
It is visible, sir.
Okay, if somebody is trying to draw something on the slide, please remove that. Don't annotate on the slide. Anyway, so I'm happy that one of you told that meta-analysis is analysis of analysis. That's very, very correct. And actually in meta-analysis, what we do is we correct some errors and biases in research findings and generalize the research results across the studies. Oh, no. So as you were already told that it is analysis of analysis, okay, and it is a process or technique of synthesizing research results by using various statistical methods to retrieve, select, combine results from previously separate but related studies. Dr. Vijay, who has done this lining on the screen? That can he remove this? Because I don't think I can remove this. It can be removed by the person only.
Huh?
Okay, and what are its usage are that instead of narrative reviews, okay, that I was telling you that 10 are significantly correlated, 10 are non-significantly correlated or something like that. So instead of that kind of narrative, we can actually give some figure, okay, one analysis about what these two variables actually says. Okay, so narrative reviews describes the literature according to a conceptual outline developed by the author, but meta-analysis does the same, but also uses a quantitative analysis of study outcomes, such as finding of the mean study outcome. Okay, and one can include a meta-analysis as part of a narrative review also. And it is also useful for summarizing. Okay, so when I say summarizing, like if you collect so many empirical works, okay, so you can use it as a theory development tool also. The meta-analysis can be used that. I will discuss that later. Okay, it is a quantitative rather than qualitative research. The studies outcomes rather are than raw data, and single independent variable and single dependent variable, it is applicable to them, and it is applicable to the same or similar design. Okay, so now we'll talk about the effect size. Okay, What is effect size? What is effect size? Can somebody tell me? Somebody is playing with the slides. Should I answer and or what?
One of the participants might have done that, sir. This is not.
Yeah, it has gone now. Please don't use those annotates or other things, okay? Any tool. So what is effect size, please? Tell me. Nobody? Okay. See, in any study, you're trying to find out some things about two variables, either correlation or difference, mean difference or something. So these numericals, what you find out, so that correlation is 0.7 or 0.6. These are called effect size. Okay. So if it is higher, it is more effective kind of thing. So it is called effect size. So nothing special about it. Okay. Whatever statistical values that you are getting, those values are called effect size. Okay. So we in this particular today will be using some two things only. One is correlation, and other standard mean difference, that is D. Okay. So all of you know that this is the formula for correlation, and it is represented by R. And what is population value represented by? Students, please. What is this? Tell me.
Row, sir.
Rho, yes, good. So rho is what? Is population parameter. Okay. The parameters can be any. It can be rho, it can be delta, it can be other things also. So rho is population parameter, and R is what? When we say population parameter, then what is R?
Sample parameter, sir.
Yes, good.
Correlation.
Correlation, but it is a sample value. Okay. So population parameter versus sample parameter. Now your studies, in any of your studies, you are only finding this R, but actually you are trying to predict about the population value from each of your studies. Okay. And similarly in this also, D is the mean difference, but delta is the population value of mean difference. Okay. So this is the formulas, very simple formulas. I think all of you know about it. So the main steps that we follow in our meta-analysis, okay, we try to find the studies with effect sizes. Okay. And then we code the effect sizes. Then we code the study characteristics. We calculate the distribution of effect sizes. Then examine the moderators. I'll talk about what all these things are. And then we draw conclusions and we share. Share means publish the results. Okay. So this is very simple steps. Okay. Now the question comes, I think somebody from CFA said that we cannot combine. So those questions are there. He was right. Okay. Whether effect size can or should be combined is controversial. Okay. Still, some people say it can be combined. Some people say no, it should not be combined. But we will accept that it can be combined if what? If both your independent and dependent variable design are identical. Okay. Only difference is the observations. That is your effect size are different. Okay. And random samples from the same population. Our assumption should be that these samples are from the same population, not from different population. If they are from different population, then we should not be combining them. Okay. Now you will say, how will you know whether they are from the same population or different population? That also I'll discuss how you will come to know about it. Okay. Then what to combine? Not safe or reasonable to combine if independent and dependent variables measures different constructs across the studies. Okay. Sometimes when you say education, you may be meaning your education may mean that number of formal years of education in schools and colleges, and somebody may be measuring it with say level of IQ. Okay. So now these are two different constructs. So those cannot be, combined. The results of such kind of studies cannot be combined. It should be same construct. Okay. I understand everybody of you know what is constructs and concept. I will not go into that. I just assume that you know about it. Then different study designs, okay, also cannot be combined. Suppose study 1 is randomly assigned conditions, and in study 2 participants are choosing their conditions. Suppose you have an action research where you randomly give some treatment to some of your samples and you don't give treatments to a randomly selected another group of people. But if you allow some people, allow them, okay, well, you can take this or not take this or not take this, then these are two different designs of studies. We cannot combine such studies. Okay, but that's what it means. And it is okay to combine if the measures are same across the studies. Okay, can use unstandardized effect size also in this analysis. Measure across all studies are parallel, can be used unstandardized. Okay, both cases. Okay, and measures are essentially tau equivalent, so same reliability, different mean and steady. We can use standardized effect size, and measures are congeneric. Okay, from the same genera. It can have different reliability, different mean and steady, but from the same genera. We can use the standard effect size or maybe adjusted model for reliability. Okay. Then studies, they have artifacts. Whatever study values that sample based studies, they have artifacts. What is artifacts? What is artifacts? Yes. It is, you can say that it is artificial fact. Artifacts are what? Artificial facts. When we say artificial means something that has been created by us. Actually, it is not there. We created it. Okay. Now, these are the artifacts that you can see below. Number one is sampling error. Okay. So, what is sampling error? See, I know this is virtual class, but I'm trying to make it as real as possible. So I request you to respond. And let me tell you one very good thing about my session. In my session, everything is correct. Nothing is incorrect. Okay. So you should feel confident enough to say anything and everything that you wish. What is sampling error?
Sir, it is the difference between population mean and the sample mean.
Okay. When you are taking the mean, okay, with respect to mean, it is the difference between that. Okay. So that means if the mean is different, the error that has occurred in the mean is because of the sampling. Okay. So you have artificially created that. Actually, there is the population mean is one and the same. So your sample should represent, if it is a representative sample, then it should represent the population mean, okay, or the population parameter, whatever mean or any parameter that you have taken. But since you don't get that, we all know that none of the sample can have exact value of the population parameter unless it is just by chance. Okay. So that is because we have drawn a sample, and because of sampling, because we have taken part of the population, we have drawn a sample, the error is there in the artifact, in the effect size. Okay. So that is how sampling error is one of the artifacts. Then another is error in measurement of dependent variable and error in measurement of independent variable. What do you understand by these two phrases? Tehniya.
Yes, sir.
What do you understand by this? Error in measurement of dependent variable, error in measurement of independent variable.
Sir, the cause and the effect, the difference between what the
cause you can explain just one of it. What do you mean by error in measurement of dependent variable?
Sir, the errors that we come across while we measure the dependent variables, I mean the cause of a particular event.
Okay. That means, suppose if somebody height is 6 feet and you measure it 6 feet 1 inch, that is error in measuring the height. Can I say that? Can I say that or not?
Yes, sir.
Similarly, if you are under measured also, then also it is error. So similarly, suppose adoption or any of the variables, okay, in our studies, if we all know the social variables are not exactly measured, okay, there can be error. So those errors are also artifacts, and these artifacts actually affects our outcome, effect size. So error in measurement of dependent variable, error in measurement of independent variables, then dichotomization of continuous dependent variable and dichotomization of continuous independent variable. This also creates artifacts. What do you mean by dichotomization? I think these are not very difficult terminologies. Someone of you should tell me.
Having only two options.
Yes, great, Dr. Rao. So what you do is, suppose you have age of the farmers, okay? So the age of farmer can be from, let us say if it is from 18 to whatever, 65, 70, whatever, okay? Now you have done one thing, that how many farmers are below 40 and how many farmers are above 40. So below 40 you give 1 and above 40 you give a score of 2. So there is age as itself is a continuous variable, but you defined it as a two variables only, as two values only, 1 and 2 or 0 or 1, whatever. Okay. So that is what if you have a continuous variable and if you have converted them into either 2 or 3 or 4 categories, then that also creates artifacts. Okay, because of why it creates artifacts? Why it creates artifacts? Students? Okay, forget about why it creates artifacts. What happens when I have done this, that age of the participant farmers up to 40 and above 40. I have done these two categories. What is happening to the data? You have only 1 to 1 to 1 to, what is happening? Prior to that, you are having so many numbers between 18 to 70 or 75, whatever, you know. What is happening? What is happening to your data? Yes, some PhD students. Please come up with the answer. Right or wrong does not matter. I think if I say the answer, you will say yes, you know it. You are reducing the variability of the data. And when you are reducing the variability of the data, your correlation or whatever you measure, that will be value of that will be affected. Okay, so that are another artifacts that we are doing this. And then range variation in independent variable and range variation in dependent variable. Okay, this is by mistake twice independent is written. It is range variation in dependent variable and range variation is in independent variable. Okay, so when we say range variation, what does it mean? What is the meaning of range variation? Yes. Similar to dichromatization, if your range is between two values and again you are varying those ranges, that also will create artifacts. Okay, so these are the things that affects our outcome of the studies. Okay, now coming to error in measurement. Okay, now I actually I'm a little disappointed when I'm not getting the answer. Please try to answer. Okay, some very simple questions only I'm asking. When I say that the reliability of measurement is 0.7, what does it mean? What does it mean when we say the reliability of any measurement is 0.7? Measurement of any variable is 0.7.
The consistency is the only up to 70% only, sir.
Yes, yes, that is true. That is true. Accuracy is 70%. But for the benefit of students, if I say this in a very simple way, if I say this in a very simple way, can I say that if something is 1, then our instrument is measuring it only as 0.7. Can I say this with safely? When we say the accuracy is 0.7, that means if something is 1, we are only measuring it as 0.7. Can I say this? All of you have studied what is reliability, okay? But have you interpreted this in this way? Can we say this, please? When the reliability is 0.7, that means something which is 1, we are only measuring it as 0.7. Suppose a person is, pardon? Somebody was trying to answer, I suppose. Yes, please tell me. I think from our class, somebody should tell.
The error may occur, sir.
Yeah, error may occur, but what we are saying is when reliability is 0.7, actually what we are trying to say is something which is 1, we are able to measure it only as 0.7. Okay. So that is what is error in measurement. We are measuring it only as 0.7. Okay. Now, can somebody tell me that something in which error is 0.7 or we have measured it as 0.7, how can we actually correct it? Knowing that the reliability score is 0.7 and you have a measurement, okay, how can we correct it? Suppose you have measured somebody height as 1.4 meters and the reliability of the measuring instrument is only 0.7. That means 1.4 is 0.7 plus 0.7. Can I say that? See. Now, suppose instrument is 0.99 accurate, okay, and 0.1 error. So, if the measurement is 0.99 and we divide it by 0.99, then the actual measurement will come. That is 1. Or reliability 9.95 something is measuring. So, we divide it by 0.95. So, we get the actual measurement of 1. Is it good? Is it okay if I say so? Is it okay? Now, what I was trying to tell you is, if reliability, that is R is equal to 0.7, okay, R means a small r, this is corrected by itself, okay, and you have measured 1.4 meters or something, okay, 1.4 say adoption or something, whatever, something you have measured. So, if we simply do this, 1.4 divided by 0.7, which is nothing but equal to 2. So your actual measurement is 2, not 1.4. But since your measuring instrument is measuring anything that is 1 as 0.7, it has measured 2 as 1.4. Is this understandable to all of you? Would you understand this? Dr. Vijay, it is becoming difficult for me to proceed. Nobody is answering out of so many people.
They are listening to you, sir.
No, listening will not help me, because unless and until they understand the fundamentals of these things, meta-analysis will be not, they will be able to appreciate it.
Sir, chat box, they are giving answers in chat box, I think.
Is it?
Yeah.
Okay. Okay. Okay, yeah, my chat box was closed. Okay, fine. Good. We have some people answering there.
I request the participants to orally give the answers.
Yeah, actually, if they give orally answer means others will also listen to it. That will make it more interesting. Okay. So am I all right in saying so that if we divide any measurement by the reliability score, then we will get the actual score? Okay, we can get the actual score. Like we divided 1.4 by reliability and we got 2. So actual score is 2. So this is a very simple method of removing the error in measurement. Okay. Now coming to the sampling error. Okay. Somebody has very rightly told that the error that occurs because of the sampling, and then the sampling, that sample values and population parameter are different. So that is sampling error. Now here, I would like to make you understand that sampling error in a very simple manner. Let us assume that these are the 12 measurements of any variable, whatever variable you can think about it. Okay, from 12 people. Okay, and you have drawn a sample of 3. Okay, which are unique samples, and you came to have the average of it. Okay, so 10, 12, and 17 average is 13. 14, 9, and 15 is average is 12.66. 13, 17, 19 average is 16.33. And 11, 12, 9 average is 10.66. Now you can see that in all these samples, the values are different. But none of the values are wrong. What I was telling you earlier, And as you increase the sample size with sampling error, we say that if you increase the sample size, then the sampling error reduces. Now here you can see. Now I have drawn 2 samples only of 6 each. Now the value you can say, here see, your value is 12.66 and 16.33 so far. Okay, almost 4.33 difference is there. But as we increase our sample size, and that is how people, scientists say or statisticians say that you should have a good number of samples so that sampling error is less. So now the mean has become 12.83 and 13.49. So it is less than 1. Okay, almost I suppose how much? 0.5 and 1.7, something like 0.66 or so. Okay, and if you take the average of the whole population, suppose this is the population, then it is 13.16, and you can see that all these figures are in and around close to 13.16. So all these figures are only indicative of 13.16, but not exact population parameter. So this is what is sampling error occurs. Okay, this is what sampling error is, we mean. Good. Now we can come back to our two most common effect size. We have talked about it. That is correlation and mean difference. Okay. So we will be using Hunter's approach about how to remove the statistical artifacts. So extraneous factors that influence objective effects are sampling error, reliability, okay, range restriction, and computational error and acclimatization. That I have already told you earlier. Okay. Now let us see with the examples. So dependent variable is 2, 3, 4. Independent variable is 1, 1, 1. Okay. So you can see that in group 1, mean is 3 and standard deviation is 1. Okay. Similarly, in group 2, we have 5, 6, 7 and independent variable 2, 2, 2. And here mean is 6 and SD is again 1. But mean of everything is 4.5 and SD of everything is 1.87. But if we pool these two SD, it is 1 only. Okay. So this is what we are just giving you some example of effect size. So now here you can see, okay, this is mean of experimental and mean of control, that is 6 minus 3, 6 and 3. 6 minus 3 divided by SD of pool, that is 3. So n is equal to 6. And similarly, the correlation is 0.88. If you calculate, it will come to 0.88. This is point by serial correlation. Okay. Now, point by serial, this is the equation for that. Okay. Now, P and Q are 0.5 and 0.5. Probability of P and probability of Q are 0.5, 0.5. And mean is 6 minus 3 divided by 1.87. Okay, this is SD 1.87. And that comes to 0.8. So actually, and now here you should note that we are not using the pooled SD, but we are using the actual SD. Okay. So the correlation is calculated this way. Okay. D by 2 divided by n minus 2 divided by n plus d by 2 square. These slides will be shared with you, so don't bother about the formulas. So that is how you got this 0.88, and difference is not 3 but actually 3.03. So if you calculate otherwise, the reliability score it is showing is 0.8, but actually it is 0.88. And similarly, the difference is not 3 but 3.03 if we use this formula. Okay. Now estimated sampling error variance. Okay. Here also, this is the formula for finding out the variance of D, n minus 1 by n minus 3 into 4 by n into 1 plus d square by 8. Okay. Now for large sample, mind it, this n minus 1 by n minus 3 becomes nothing but 4 by n. Okay. So the error is NE minus NC divided by NC and into NC, NE into NC plus d square by 2 twice NE plus NC. Okay. So estimated D is nothing but we have to have this adjustment, and this bias adjustment is there is a formula for that, 1 plus 0.75 divided by n minus 3. So if you do this, then you get estimation of D. Okay. Now we just come to some analysis. Okay. Let us assume that the mean population parameter is 0.5 and SD of this is 0.1. Okay. So D is equal to 2R by under root 1 minus R square. So it will be 2 into 0.5, this one, divided by under root 1 minus 0.5 square. Okay, this is nothing but 1.1547. This is very close to your delta. Okay, this is nothing but estimate of the delta. Okay, and the standard deviation of this is, the formula for that is this one. Okay, so d is equal to 2t by under root n, r is equal to t oblique. These are the conversion. You can do conversion from this. Okay, the d, r, and t, all these things can be converted from each other. Now again, if you see here, the difference, weighted difference. What we do here is we take actually weighted difference. So this is the formula for that. I'll not go into the formula. Okay, I'll just go with the examples where you can understand better. So there are 4 studies that we have taken, and mean difference is 0.2, 0.3, 0.4, 0.5. So if we take unweighted mean, then it will be 0.35. Okay, and let us assume that the sample size is 30, 60, 50, and 100, and the mean sample size is 60. Now let us see next. So what we do here is we multiply d, that is the mean difference, with the respective sample size. So you get DNI. Okay, so DNI is nothing but what you are getting is 6, 18, 20, 50 for these studies. Okay, this is what we have, I have told you earlier. Okay, so this is what you got. So sum of NI is 250 and sum of DNI is 94. So now if you have this weighted DI, that is 94, divided by sum of the weight, that is 240, this one. So it comes to 0.39. Now note here, when it was unweighted mean, it was coming to 0.35, but this actually unweighted is not correct, because somebody I think was telling us that different sample size is there. How can we make you can unify them? But if you take weighted means, then you can unify, and this is a right value of difference. Now here you can assume that, see, individual studies were 30 size, 60, 50, and 100. But this result, we can assume that it was based on a sample size of 240. This is the beauty of meta-analysis. Without collecting data from 240 samples, by just combining the results from 4 studies, you got a data. And as I told you, here, sampling error, that as you keep increasing the sample size, the error will keep reducing. Okay, so this is what is happening here also. So with 240, I think all of you will agree that the sampling error has reduced just by adding these results. Okay, similarly, then let us take this one. Okay, so it's this we have found out the mean difference. Now what is the variance of that? That we can find out from weighted variance. Now we have NI, D, NI, and NI into D minus D bar, that is mean of it. Okay, so these are the values that we have got from this, and when you sum all those things, this is 2.78 divided by 240, which is nothing but 0.012. Now the variance of all these studies combined is 0.012. Okay, so what happens is, when the sample size increases, variance also will not be too much. It will be very close. Okay, now let us take another example here, that D bar is 0.39, N bar is 0.6. Okay, now this is, I think, yeah, no, not another example, the same example is continuing, and K is 4 and variance is 0.12. Okay, so now the error I have told you this is the formula for finding out the error in population. So it has come to 0.07. Okay, and this one is variation in D and minus variation of error. So variation of D is 0.012 and error variance is 0.07. So it comes to minus 0.06. The variance cannot be minus, so we can assume that it is 0. Okay, so now you can understand that there is no variance when we have combined them. So the confidence interval, okay, or credibility interval, we can we know the formula is for this, for 95% confidence interval. This is the formula, d bar plus minus 1.96 underscore under the root, this one, and the value comes is 0.29 to 0.50. Okay, and if we say the credibility interval, sorry, this is credibility interval, and this is credibility interval is CR and confidence interval is CI. Now this is two values are coming very same, so it is very highly credible result that we have got. And large sample confidence interval for population mean, we have this formula. I think this formula we all know. X bar plus minus variance divided by under root of n. Okay. So these are various Z critical values for that. 2.58, 1.96, 1.64. These are given in our textbooks also. Now let us take the example for here about the correlation also we are bringing in. I was talking about only the difference earlier. So let us consider that these are the studies with 100, 30, 40, 50 sample sizes. Total is 220 sample size. The mean sample size is 55. And the differences are 0.2, 0.2, 0.4, 0.4. So the mean difference across the study is 0.3. And the correlation is 0.9, 0.8, 0.85, 0.9. So the mean correlation is 0.86. Okay. And weighted difference is 26, 16, 20. So the mean weighted difference is 62. Okay. And accordingly, this is your corrected difference. Okay. So this is nothing but 0.21, 0.22, 0.43, 0.42 instead of 0.2, 0.2, 0.4, 0.4. And these things you can see this has come because of the sample sizes. Okay. So when we say the mean of difference, then we get this weighted difference divided by total weights, which is nothing but 62 divided by 220, this one, and we are getting it 0.28. And earlier, see, here it is coming 0.38. Now 0.3 is not correct. Actual correct difference is 0.28 for the population. This is much closer to the population parameter. Now coming to this, okay. So this is the same data that is we are continuing. Okay, only we are adding some more things. So the weightages are here, number of sample size, difference, correlation, and these are the weights. Okay, these weights are we are getting from multiplying this multiplied by this multiplied by this multiplied by this multiplied by this. So you are getting 90, 24, 34, 45. So 193, and this scores we have taken here. Okay, we have already calculated here. So these are those corrected D, and weight into DC. This will make this one, so 58.07. So corrected D is nothing but now we will have to do this 58.07 divided by 193. Now it comes to 0.3. Okay. Now going further, the same studies, these are DCs that we have calculated. These are the weights that we have earlier calculated. Now we are making the difference from the mean. So these are the values, the weight into the differences square. So these are the values that you get, and the sum of it is 2.3. This is which is 193. Variance of error we calculated as I showed you the formula. So these are the value for that, and errors are 0.5. These are the errors. So weight into error is this one. So total of it is 16.93. So the variance of D is nothing but weight into this one, summation of this. Okay. So this we know is 2.13 divided by 193. That is summation of all the weights. So this is 0.01104. And error variance is, we have seen this formula earlier also. Okay. So when we calculate that error variance, so it will be 16.93 divided by 193 is 0.088. Okay. Now we know that this is the formula for error variance for the population. Okay. So we can predict for the population. Now the summary is that DC is corrected, D is 58.7 divided by 193, that is 0.3. Variance is this, okay, and error variance is this, and population variance is minus 0.076. Since it cannot be minus, so it will be 0. And accordingly, you can see that 95% CR is same, 0.3, 0.3. Okay. Now coming to correlation between dependent variable and independent variable. Anything that you would like to ask me at this point? Any one of you? Mean difference, how to correct mean difference and its variance, those values, those formulas I have shown you. Okay. So, okay, if there is nobody saying things, that means I can understand either you have understood everything or you have not understood anything. So I will try to take the benefit that you understood everything. Fine. So we'll go to the correlation between dependent variable and independent variable. Okay. Now, as I told you that as in the case of mean difference, we were taking the weighted mean, okay, and weighted variance. So here also for different studies, whatever correlation is there, we will multiply it by the sample size, and sum of the sample size we will divide it. So whatever for score that will get is a mean R, which is quite close to the population parameter. Similarly, its variance will be calculated with this formula, okay, because we have got mean R. So we will find out the variance of R using this formula. We all know the formula for variance. So this is how you will get that, okay. And so there are case studies with NI observations, okay. So this is the formula. This is for mean. This is for standard deviation, and this formula we all know is for the confidence interval. So R plus minus 1.96 into under root this one, variance square, variance divided by K. K is the number of studies. Okay. So this is not the only formula we use, but it is the best one. That is what we say. So estimating the variance, sampling error variance. So this is how we try to estimate that if this is the population parameter, this is what variance we have, 1 minus this one. So this way we estimate what is the population variance. And variance of rho also, X is equal to nothing but true variance plus error variance. Okay. So here also same thing. This is the classical test theory. So sampling error is nothing but R is equal to population parameter plus error. Whatever R we are, this error can be plus or minus. So accordingly, this will be more than population parameter or less than. Similarly, variance is nothing but actual population parameter variance and error variance. Okay. So simple one. This goes this side. Variance of R minus error variance will give us population variance. Okay. So this is how we calculate this. Okay. And this is the credibility interval. We have already talked earlier. Okay. And this is the formula for testing the variation across the studies. So there are case studies. So chi-square of k minus 1, whatever value, is equal to the true variance divided by this. This will give you, if this is significant. Okay. So if there is a moderator value, the value of chi-square will be significant. Okay. Now coming back to, I think Dr. Das was telling that the studies are from different population or something. How do we know that? So if these case studies are actually from different populations, then this chi-square value will come significant. And if these case studies, number of studies that you've taken is from the same population, then this won't come as significant. So what we try to do is, if you found out this to be significant, then what we try to do is we try to identify moderator variable. Now what is moderator variable? What is moderator variable? Okay. The moderator variable is some kind of variable that you try to identify and try to understand that why these studies have significant chi-square. Now, one of the moderator variable, suppose I have 20 studies, 10 before 2000 and 10 studies after 2000. So I can take a moderator variable as the duration of the study. So before 2000 and after 2000. So now I will subgroup it. Again, I will find out the mean R and all variance, everything, and then find chi-square value for these two groups based on before and after 2000. So if the chi-square value is not significant, then we can say that the correlation value was such before 2000, but after 2000, these two variables have changed to be behaving in different way, and after 2000, the correlation is positively significant or something like that. Or else, you can also do it that the studies conducted in northern India and studies conducted in southern India. So there are cultural differences, we can say. So with that kind of study, two groups also, if you find that, okay, by segregating the studies, k number of studies into two groups, we found that chi-square is no more significant. That means the variables are operating differently in south and differently in north. Okay. Now these studies can be combined. All studies conducted in south can be combined. All studies conducted in north can be combined. Or it can be Western India, Eastern India, or it can be whatever. So these are the moderator variable. Based on you keep dividing the studies till the time you don't get chi-square significant. Okay. Now I will come to some examples here. So these are 4 studies with sample size 200, 100, 150, 80, and we have the correlation values like this. These are all hypothetically made so that you can understand better. Okay, and these are the reliability score of X and reliability score of Y, different instruments. So the mean reliability, population size is 132.5, mean correlation is 0.3, mean reliability of X is 0.8, mean reliability of Y is 0.85, sorry, 0.85, and UX is 0.13. Okay. Now, if we multiply correlation with, now we are trying to find out the weighted correlations. So if we multiply these correlations with the sample size, we get these values 152 and sample size is 530. Okay. So what we do is we sum of Ni into Ri. This is Ni into Ri. Okay, 152 divided by sum of Ni, that is 530. Okay. So the mean R is nothing but 0.2865. Okay. So, but if you calculate here, mean here is, it may come as 0.3 because 0.2 plus 0.2 plus 0.4 plus 0.4 will may come 1.2 divided by 4 will come 0.3. Okay. So yeah. So this is actual is this one. Okay. But when we say get unweighted, it is only 0.3. So actual mean correlation is 0.2868. Okay. Now, if we try to get this, what is the difference between mean and these values, and multiplied by these weights? So we get these values. 5.2 is the sum of it, and 530 anyway sum of population this one. So R bar is mean R is 0.2868 and N is 132.5. This is what we have. Okay. And number of studies are 4. So the variance is, we can calculate by using this formula. This is coming 0.009828. Okay. So error variance we'll find out is nothing but 0.006405. So the population variance is this variance minus error variance, which is 0.0034. Okay. So the confidence interval is 0.19 and 0.384 for R. Okay. And credibility score is minus point. Actually, it cannot be minus, so but you can assume 0 to 0.4. Okay. So now we'll see this. Okay. So corrected R is nothing but your correlation of XY divided by under root of reliability of X multiplied by reliability of R. This is what we have done. And corrected correction for independent variable is this, and correction for dependent variable is this formula. You know, I have explained you all know that if you just divide a true score, if it is divided by the reliability score, so sorry, measured score divided by reliability score, you will get the true score. So in case of correlation, you have to go for under root of that. Okay. So you get, suppose RXY is 0.3, RX and RY is 0.8, then corrected R is 0.3 divided by under root of 0.8, which is nothing but 0.375. So this is the corrected correlation of individual studies, 0.375. And this is the corrected this one, reliability of independent variable. Okay. Sorry, 0.3 divided by 1. Yes, the same thing. Now this is what is range restriction means when your samples are drawn from like this. So you have range restrictions. Okay. So these are some of the examples of range restrictions. I'll not go into range restriction. So meta-analysis of corrected R, if the information is available, can correct R for each studies and compute the corrected values, and then can also be done for assumed distribution and but I don't recommend it. Okay. Okay. These things I am not going to cover here. Now another example, I think the same example is here. So this is the way you have to conduct it. So the same thing. Range restriction I am not covering here. So meta-analysis is useful for summarizing empirical work. Okay, that I've already told all these things. Rather than theoretical work, it is quantitative rather than qualitative research. The studies outcomes are rather than raw data, and single independent variable and single dependent variable data on the empirical relations among measures of IVs and among the measures of DVs can be brought to bear, and same or similar design should be there. And this meta-analysis is useful for theory building. Now, why I say theory building is because suppose if you have taken 20 studies of 200 sample each. So your meta-analyzed results is something like a study conducted with 4,000 samples and randomly selected from 20 different locations, So whatever result is there, that is very much close to your population parameter, as I have shown you earlier. So what is theory? When you are able to predict about the population parameter, that is theory building. So meta-analysis can not only be used for review of literature, but also for theory building. Okay. Now these are some of the references that I would like you to go through. I've anyway shared the slides. So particularly I am fond of Hunter. So you can go through that. Glass actually started working very early on meta-analysis, but Hunter has made it very, kind of easy to follow. Glass will be a little bit tougher. Okay. So any question here? So in nutshell, let me summarize again. What we are doing with correlations is we are going for weighted correlation. Okay. So mean of weighted correlation is better representation of correlation from the population. And what we are trying to do is by removing measurement of, that is when we give the weighted correlation, then sampling error is reduced. Okay. It is not eliminated, but at least it is reduced. Okay. And then measurement of error in measurement of independent variable or dependent variable is corrected by dividing it by the reliability scores. Okay. So that is how you get the corrected values, further refined values of correlation or the difference. And these corrected values of correlation and difference can be said as the actual representation of population parameter. So now we can summarize that in this, what I was telling you earlier, 25 studies where 10 are positively correlated, 10 are negatively correlated, and 5 are uncorrelated. So if you combine all the R's by weighted and then dividing it by the reliability scores and other things, then you get one figure of R, okay, correlation, which is very, very close to the population parameter. So this is how you are in a better position to summarize than telling that 10 studies are showing positive, 10 studies are showing negative, and 5 studies are showing no correlation, although my study is showing positive correlation. Okay, so this is how I would like to summarize my today's presentation. So Dr. Vijay, I invite questions, and I want to tell you one thing. Please don't bother about the mathematical part of it, because those things are taken care by the statistical, all analytical tools are there. So those things can be taken care of. No, vote count methods are not meta-analysis.
Can we?
Yes. So is it, do you appreciate now that meta-analysis is better way of review of literature than just telling that this many numbers of studies are positive, negative, uncorrelated kind of thing? If every one of you agree with this, then I would like to encourage you to go for meta-analysis, and you can contact me later if you want to have any problem. What is the limit of studies for meta-analysis? Wonderful question, Dr. Das. Thank you. Minimum and maximum. Fine. See, suppose if I combine two studies, so both of 100 sample size each. So my result will become a study conducted on 200 sample rather than 100. So since the sample size has increased, naturally the correlation value that I will get by combining two studies is closer to population parameters than individually each study. And I would like to again share my screen here. This one, sampling error. Now see, the moment we have combined this one, we are becoming closer to population parameter. So even if it is less number, 2 also, you combine 2. If you have got 50, you combine 50, no issue. But if it is significant, chi-square is coming significant, then you have to find out what is the moderator variable among these studies. Okay. And as I told you, it can be year of the research, it can be regions, it can be some other things. Okay. You can just get into those studies and find out, and then make segregation and again go for meta-analysis. And then you will, if you get non-significant value of R, then that holds true for that group. So no minimum, no maximum, everything is good. Yes, please.
Any more clarifications?
Dr. Vijay, I take it. If there is no question, means they have understood.
I think you have answered all the questions posted in chat box. Yes, sir?
Yes, but I know from my experience. See, I used meta-analysis in 1990. Okay, but I have not come across many students of extension using it. Okay, so this is almost more than 30 years I have gone. So only request to all the students and all the faculties and scientists are, please don't get bogged down with the formulas, because statistical packages are there which will do meta-analysis for you. All you have to do is collect the studies, collect the effect sizes and correlation values and other things, and then try to combine the results. Okay.
Sir, all the participants are thanking you for your valuable presentation, in fact.
No, I'll be happy if they will use it. Presentation is okay. Presentation, because I had to hurry it with, I saw that the time is lot of time I was taking, so I hurried through the slides. But if anybody is actually interested to use it, then they can always contact me. And I think Dr. Sawa, you can give my email and maybe phone number to them, whoever is interested.
Sir, it seems the presence of the participants also throughout the session, it is around 225. All the
Yes.
225 think listen to you for 2 hours continuously. And continuously their thanks messages are there in chat box.
Yes, I can see it is coming. It's
Sir, really, I thank you very much,
can
sir.
we know name of some software? You type it in meta-analysis in software for meta-analysis. There are a number of softwares. Okay.
Sir, can you please provide the presentation? I mean, your presentation that you just
Yeah.
presented.
It is there with
It will be
Dr.
shared, ma'am. It will be shared to all the participants. Okay.
Okay, sir. Thank you.
Yeah. I have collected. Yesterday's presentation also is with me.
Yes, sir.
I will email to all of you. Okay.
Thank you so much, sir.
If anybody is not receiving, please kindly let me know. I will send through WhatsApp also. That's not a problem. Okay. So let us thank today's speaker, Dr. G.A.K. Kumar Garu. In spite of his busy schedule with other core personal activities, he agreed and had made it possible to be here with us for 2 hours, right at 2 p.m. itself. From 2 p.m. was in fact, I
You can
insisted
see
on
this only yesterday I got freed from this some rituals. So that's what.
Because time has been given to all the participants. So
Yes.
For that reason only, I insisted upon it. Please excuse me, sir.
No issue. It is always pleasure talking to students and faculties. It is always
In
pleasure.
fact, we were continuously talking each other on several issues related to our field. But you made it possible, sir. Today we have come online and could see you in person. Okay. Let me thank on behalf of the Department of Agriculture, Extension Education and our staff, and also the Agriculture College, Bapatla, and also Acharya Engineering Agriculture University, sir. Thank you immensely. We'll be in touch with you, sir. We'll have several that is online classes from your side to our PG students and PhD students of the university, sir. Thank you. Thank you all the participants. In fact, you have yeah, please. Hello?
I am from Raichur.
Raichur, Tulsiram.
Yes.
You want to say something?
Yeah, that presentations. Yesterday, just I missed. We have the ICAR admission lecture seats. So from today onwards, I am attending. So I request you to send those presentations to emails. Better.
Yeah, definitely. I will share all those presentations.
To emails.
Okay, definitely. Tulsiram, I will send you. Okay.
So,
Dr.
I only wanted to stress once more. See, when I was asking the questions, many fundamental questions, you have yourself witnessed that many people are not coming up with the answer. Okay. That also one way shows that we just have some idea about what is research, what is this, what is that, but not a great understanding of it. So particularly for students, I will be very much interested if we can have some very fundamental and basic kind of sessions where all such concepts are well understood. That helps, I tell you, sir. If the students understand the fundamentals very well, that will certainly help them. Okay.
Definitely,
so
we will have.
Let us plan for that.
Sir, definitely we will have continuous sessions with you. If you are agreeing to our request, definitely let us make our students knowledgeable and competent in the Sir,
ఇది ఆన్లైన్ ఎక్స్పెన్సివ్
తులసిరామ్ గారు మ్యూట్ చేసుకోండి. తులసిరామ్ గారు ప్లీజ్ మ్యూట్. ఓకే సార్, ఎనీ ఫర్దర్?
I would like to thank you for giving me this opportunity, and more than 225 people were listening to this presentation. Only possible because of your so much keen interest to spread the knowledge among every one of our colleagues and the students. So I would also like to thank you very much, and your college and your university. Let us hope to again come and meet so that actually meta-analysis has some more parts, but since the time limit was there, I have cut short many things. So maybe I will go for some higher things if possible, not this time, but some other time. Okay.
Okay. Thank you, sir. Thank you.
Thank you so much.
Thank you. Let us call it a day. Tomorrow we will meet again at 2 p.m. sharp. Okay. Thank you very much. Thank you all. Thank you all the participants.